Hello guys, welcome back to my channel. Today we're gonna solve LeetCode problem number 70, climbing stairs. As you can see, I have already solved this problem. Just few minutes ago, I made a video for this, but actually it wasn't recording, so I have to make this video again. Um, yeah, fine. This is an easy level problem. Let's just go to the description once. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct way you can climb to the top? So basically there is a staircase of n steps, and we can climb either one step at a time or two steps at a time. And how many ways we have to find, in how many distinct ways, we can reach the top. Fine. Let's just go through the examples to get a better understanding. Input n equals to 2. Explanation that is given. There are two ways to climb to the top. Either we take one step at a time or directly jump to the second step. Yeah, there are two distinct ways. So we are displaying output as 2. Example number 2, n equals to 3. There are three ways to climb to the top. First thing is like we can take one step at a time, or we can take one step then two step, or two step then one step. There are three distinct ways. Yeah, it's understandable. We got an idea. Um, Constraint. Let's just go to constraint. N is greater than 1 and less than 45. So we have to solve this in complexity of n square, like equals to or under the complexity of n square. Fine. If it was less than 30, we could have directly solved. If it was less than 20, we could have directly solved using brute force, that is 2 raised to power n complexity. But since we have to solve it under n square or equal to n square, we can do one thing. This problem seems a lot similar to Fibonacci series. So Fibonacci series is basically, if you don't know, I'll draw it. So in Fibonacci series, basically we have two elements, 0 and 1. If you want to find the third element of Fibonacci series, we do sum of the previous two elements. For the third element, the addition of first and second element, the previous two elements are 1. For the fourth element, addition of previous two elements are 1 plus 1, that is 2. For fifth element, addition of previous two elements are 3, and then 4 and sorry, not 4, 5 and 8. So it goes so on. So usually in Fibonacci series, we are asked to find for nth index, or for nth element of Fibonacci series, what is the value. So basically that's asked, we are asked that question in here. We are also asked n step. If we remove this first two elements, then this is similar to Fibonacci series. So we get an idea. And how do we solve Fibonacci series? We usually solve it by using recursion, but it takes 2 raised to power n. We can implement memorization in that to reduce the time complexity. And how do we reduce it? So basically recursion usually doesn't keep track if certain subproblem is solved or not. We basically add a list, and we add the computation, what is the computation result of that sub problem. So in future, if our problem refer to that sub problem in one of the instance, we can directly take it from the list, and like we don't have to compute it, we can refer it from the list. So basically our time complexity reduces to n. The same way we can do it in here. For that, we'll declare a list dp. Basically dp will be the name of list. Let's say each index has 0 number initially, and we are gonna, because we are starting from 1, we are not starting from 0, and we have to calculate for nth step. If we have a 0 index array, it will start from 0 till n minus 1. If you are declare n, it will start from 0 till n minus 1. But if you are declaring for n plus 1, it will start from 0 to n. So that's why we are taking n plus 1. And we can declare if n is less than equals to 2. So let's say we are asked to find how many distinct ways are there to reach first element. So we can just declare it return n. For first, if there are n steps, we can reach there in n number of ways. Like if there are one step, we can reach in one way. If there are two steps, we can reach in two steps, right? We can say it anywhere. As well as we can declare same for the array. dp of 1 is 1, dp of 2 is 2. Or then we can declare a loop for I in range 3 till n plus 1. Why we are taking n plus 1? Because it will run till n. Basically, it excludes the last element that we have declared. It will run from 3 to n. What will we declare inside the loop? dp of I. What is dp of I? dp of I will be summation of uh, previous two element. dp of I equals to dp of I minus 1, dp of I minus 2. And then what we are going to return? We are going to return dp of n. So basically this is the top down, this is a bottom up approach, right? We are starting from the base and we are reaching till top. So I think everything is good. We can run this. Let's just go through our code once again. Mm, I don't think there's any mistake in here. Okay, well, let's try running this. Let's see if it covers our given scenarios. Yeah, it's covering the given scenarios. Let's just try submitting this and see if it covers our hidden scenario as well. Yeah, it's covering our hidden test cases as well, and it's beating almost 100% of the solution. So basically what is happening here is it's taking O of n time because we have only one loop. Each like all the other steps are taking just one. Okay, let's say if we are declaring this. Not sure if declaration takes one instruction. Declaration is a one instruction or it is multiple. I think it's a one instruction. So this is one, this is one, this is one, this is one. But this is one step. It is been iterated over almost n minus 3 times. Basically O of n complexity or time complexity is O of n, and memory we are taking extra memory of uh, basically n. So this memory is also O of n. Memory complexity is also O of n. So in this way we have solved this DP problem. I'm gonna try to attempt uh, quite more DP problems because this is very essential for interviews and as well as contests as well. And I'm planning to upload at least 6 questions a day. That's my target for different topics. Six problems with different topic, which is gonna cover DP, graph, greedy, brute force as well, mathematics. Like all these topics need to be covered. So my goal is like by end of the month we can have somewhere around 180 problems if you solve 6 problems a day. Yeah, that's the plan. Let's try implementing the plan. And if you have any questions, you can drop it in the comment section. If you have any suggestion, feedback, or constructive criticism, you can drop it in the comment section. I'm gonna go through it. Yeah, thanks. I'll see you guys tomorrow.